Yeah. Now let us discuss a few other problems. This example 2.3, the resultant of two forces P, which is given along AB in this direction, and 30 Newton, which is given along OA in the figure, is the resultant is 40 Newton, which is given along this OB, inclined at an angle of 60 degree to the 30 Newton force. So this angle is given to be 60 degree. Find the magnitude and direction of P. So in this case, the resultant is given, which is 40 Newton. And these are the two forces. The first one is this one, and the second one is this one. Okay, so that means 30 Newton is the first force, and P is the second force. P is the unknown, which is we have to find out using the analytical method. So here we can apply the knowledge of trigonometry to find out the side, the magnitude of P. So here you can see that here AB square is equal to OA square, OA square plus OB square, OA square plus OB square minus 2 OA OB cos 60, because this angle is given to us, angle 60. So we can find, we found the P to be 36.06 Newton. Now applying the sine rule, that means this side, which is P divided by the sine of this angle 60, is equal to 40 divided by the this angle, which is unknown because we don't know the angle right now. We found the magnitude in this but not the angle. So this is 40 divided by sine of 180 minus theta. So here in this way you can find out the angle theta, which is coming out to be 106 degree. Okay. Now coming on to the next problem, you can go through the 2.4 also, but 2.5 is I find worth discussing here. So in this, two forces of magnitude 3p and 2p respectively acting at a point have a resultant R. If the first force is doubled, the magnitude of the resultant is doubled. Find the angle between the forces. So here the unknown quantity is theta, angle between the two forces 3p and 2p. Now the resultant of in the first case, when the forces are 3p and 2p, 3p square plus 2p square plus 2 into the first force 3p, second force 2p into cos theta. So this is the value of r square. Now in the second case, the statement says that on doubling the first force and doubling the resultant force, uh, we get the resultant which is doubled. Okay, on doubling the first force we get a resultant which is double. So r becomes 2r, 3p becomes 6p, and this 2p, there's no change, so 2p becomes 2p, and here again this is 6p in place of 3p and 2p into cos theta. Angle remains unchanged. So this is the new equation that we found, and this is equal to 4r square is equal to 4tp square plus 24p square into cos theta. Now substituting the value of r square, which is common in these two equations, you can get the value of theta. Because theta is the unknown, we have to find out the angle theta, which is coming out to be 120 degree. So this was problem number 2.5. Now I want to discuss 2.7. Two equal weights of 10 Newton are attached to the ends of a thin string which passes over three smooth pegs, just like this you can see in this figure. Okay, so which passes over three smooth pegs in a wall arranged in the form of an equivalent triangle with one side horizontal. Okay, find the pressure on each peg. So let A, B, and C be the three pegs. That means this one is A, this one is B, and this one is C. So there are two equal weights, that is 10 Newton here and 10 Newton here, on pegs B and C. And we have to find out the reactions at this B and C as well as A. Okay, so again read the statement. Two equal weights of 10 Newton are attached to the ends of a thin string which passes over three smooth pegs in a wall arranged in the form of an equilateral triangle with one side horizontal. Okay, and find the pressure on each peg. So this is the equilateral triangle, represented as a equilateral triangle, and one side of it is a horizontal. So this is shown like this. Okay, now ABC are the three pegs, and let there be three reactions at these pegs. So tension at here is given to be 10 Newton, here again 10 Newton. Now if we apply this the resultant of at any point. Okay, so resultant at any point is given by the p square plus the square of these two forces plus 2 pq cos theta, because you see here we are applying the parallelogram law. Okay, because you see both the forces, like for A. Okay, no, sorry, for B, let us see, this is the actually T forces like this outwards, and this 10 Newton forces is again outwards. So here we can apply the parallelogram law of forces to find out the reaction. So the angle here is 120 degree. Okay, so sorry, 90 plus 60, it is 150 degree. So here we apply this parallelogram law of forces. So here RB square is equal to 10 square plus 10, because the tension is considered to be equal to the force being applied, because it is a common string. So remember that this RB is not a string, this is just pointing out the reaction force. Okay, so in this way we can find out the value of RB, which comes out to be 26.8, and similarly you can find out the angle also of the reaction using the formula that we have discussed in the parallelogram law of forces. And similarly this RA, which is again subtended angle is 60 at this peg A of between the two strings. The tension here is T 10 Newton, here 10 Newton, angle is 60. So again we can find out the reaction, and similarly you can find out the reaction at C. Okay, now let us come to discuss the next solved problem, which is example 2.9. A particle is acted upon by the following forces: a pull of 8 Newton due northeast. So northeast, you can see if it is a north, so north, this is east, west, and south. So northeast means angle of 45 degree with the horizontal or east. Then a pull of 10 Newton due north, which is along this direction. A pull of 12 Newton due east, which is along this direction, horizontal. And then a pull of 4 Newton in the direction inclined at 60 degree south of west, which is along this direction. And a pull of 6 Newton in a direction inclined at 30 degree east of south. East of south is this one. So 30 degree east of south is this direction. So without actually going to the solution, I will only discuss how to solve it. The first of all, we will find out the horizontal component of all the forces. Then we will find out vertical component of all these forces, because we know the angles that they are making. And remember one thing, when you are finding out the angles. So, for example, let us take the example of this 60-degree angle which this 4 Newton force is making. So, one way is you take the total angle to be 180 plus 60, which is 240, and you find out sine and cos with this 240 angle. 240-degree angle. So that is one way. So in this, you don't have to take care of the sign conventions, because positive or negative, whatever, will come automatically when we say that the angle is 240-degree. The other way is you take this angle 60 and take care of the direction. That means it is going in the leftward direction, it is going in the downward direction. So both horizontal and vertical components, they are in the negative. Here for 12 Newton it is positive, here both the are positive. Here one is positive, that means x is positive and y is negative. So all these things you can take care of in this example when you actually solve the problem. Now, let us discuss. So, this is all the examples that I wanted to discuss in this chapter. Based on the discussion that we have, you can solve a few problems from the solved one as well as the unsolved one to uh, further reinforce your practice in this. Okay, thank you.